All right. Task number 4, peaches and plums. Graph below shows the cost. The graphs below show the cost of buying X, cost Y of buying X pounds of fruit. One graph shows the cost of buying X pounds of peaches. The other shows the cost of buying X pounds of plums. Which kind of fruit costs more per pound? Take, whoa, why? Okay. Peaches. Can we get a little mathy about that answer? No, there we go. Peaches. Steeper slope. Matthew? Catch that? Steeper slope. Okay. Okay, number 2, bananas cost less per pound than peaches or plums. Draw a line alongside the other graphs that might represent the cost Y of buying X pounds of bananas. Go. Where does it go? Below the plums. Why? Because it's cheaper, so it has to have a smaller slope. Yeah. So somewhere like that. And bananas. Is that it? I will, yeah. Isn't there another question at the bottom? Oh, that's just, yeah, no, I know the lesson. All right, you guys love these. I'll collect that at the end of the period, yeah. Task number 5, independent versus dependent. You guys love these questions. For each, what's that? Yeah, which one makes the other one change? For each situation, identify the independent and dependent variables. Jaren? Height of grass is one variable, and the time of the year, the time in the summer, is another variable. So independent is summer, and yeah, but the main thing is the question you're asking is which one affects the other one. So it doesn't matter whether it's making the grass taller or shorter or dies or whatever. It's summer affects the height of the grass. Wouldn't it be cool if the height of the grass affected the summer instead? You like cut your grass and then make it not be like summer go slower or something? Right, but it doesn't affect. No. Nice try though. The sun does not absorb any oxygen from planet Earth. Westone. Okay. The independent is the number of students, and the dependent is the number of buses, because the number of buses you need depends on the number of students you're going to take, right? Okay, how about number 3, the weight of your dog and the reading of on your scale. Talia? So the reading on the scale depends on how much your dog weighs. Sounds good to me. The reading on the scale depends on how much your dog weighs. Yeah. Alrighty then. The amount of time you spend in an airplane and the distance that you are flying. Akerna? Yeah, the time that you spend on the airport depends on how, or on the airplane depends on how far you're flying. The farther you fly, the more time you have to spend, obviously. The distance you fly depends on how. It could go the other way, yeah. But usually you like pick the distance and then the time, you know what I'm saying? But like if you were on a, like just like on a pleasure flight, then you could flip it around and just be like, oh, how much time do you want to spend up here? You know, I don't know. But yeah, you're right. Nathan, number of times you dip a wick into hot wax and the diameter of a handmade candle. What is it? Diameter? Yeah. I like that. All right, next one, the amount of money you owe the livery and the number of days your book is overdue. It's going to be Matthew. It's going to be Matthew. Dang it. Luis? The days the book is overdue is the independent? Uh-huh. And the money you owe. The money you owe depends on how many days overdue the book is. Yeah. Good there? Those seem like they were easier than the ones that we did before. Oh, there's more. Number of homework assignments you haven't turned in and your grade in math. Oh, this would be a good one for Matthew. That'd be even better for Alexa. Matthias? Grade of math is what? Grade of math is independent? Dependent. Right, your grade depends on. Yeah, your grade in math depends on the number of homework assignments you turn in, and of course, how well you do those assignments. Did everybody go? Dylan? The time? Don't overthink it. You got it. The temperature of the milk depends. Oh, okay. Okay. Because that's the order you say it in, right? Yeah, you say the temperature of milk depends on the time out of the fridge. But since you said the temperature of milk depends, that means it's the dependent. It did, yeah. 10 copies front back stapled. 37281. 37281. You good, Dylan? Okay. Luis? The weight suspended from a rubber band and the length of the rubber band. Yep. The length that the rubber band stretches depends on the weight of the thing being suspended, therefore the length is the dependent variable. Did you say this is a long one? I bet we, oh, look at this. There's more. These are the last two? Nathan? Diameter of its pizza, diameter of the pizza and its cost. You got it. Cost of the pizza depends on its diameter. Hope so. It's pretty easy. McKenna? Number of cars on the freeway and the level of exhaust fumes in the air. Number of cars is independent and the exhaust level is dependent. The exhaust level depends on how many cars there are, yeah. Okay, any questions about that? Those easier than the ones we did before? Yeah, those seem really easy. There were no places there where Matthew could jump in and go, hey, what is? Okay. Alright, next one, coffee by the pound. Lena paid $18.96 for 3 pounds of coffee. What is the cost per pound for this coffee? How'd you get that? Okay. So Matthew took the cost and divided it by the pound, and he got the cost per pound. Okay? He is none. Disagree. Disagree. Yeah. You can buy less than a pound. I think, don't they have those things, I don't drink coffee, but where you can like pour it into a thing and then it weighs it or whatever? Yeah, like you don't have to buy the whole thing. So how do you figure out if, Matthew, you're not wrong, if you can buy less than a pound, how do you use the fact that it's $6.32 per pound to figure out how much you can get for $1? How do we figure this out? Yeah. Right. So if I wanted to know an exact answer, divide what? If I divided $6 by 1, I would just get 6. So you're on the right track, but you're the other way around. I want to divide 1 by $6.32. I want to divide the $1 that I have. Yeah, so what's 1 divided by 6.32? Okay, so about 0.158 pounds of coffee. So yeah, you're right. I mean, you can't buy any pounds. Yeah. Okay, identify the independent and dependent variables for this problem. Which is the independent, which is the dependent, the cost of the coffee? Independent. What are you hitting me with? You know what? Yeah, I think this is one of those that could actually go both ways. In the way this problem is stated, she's got $1, so the amount of coffee that she can buy depends on that dollar. But I would guess most of the time people don't do it that way. People buy a certain amount of coffee, and then how much they pay depends on how much it weighed. But really, you could go either way. Yeah. Does that make sense? Usually I would say that the cost depends on the weight. But the way they asked this question, the weight was depending on the cost. So, okay, draw a graph in the coordinate plane of the relationship between the number of pounds of coffee and the price of coffee. So now we've got to decide which way we're going to go, because the independent one always goes on the X and the dependent goes on the Y. Yo. How much it costs depends on the weight. Okay, so I'm fine with that. So that means that this is going to be, go. That means, well, he just said the opposite thing. He's just decided that the cost depends on the weight. So that means the, okay. That'll make the graph a little bit easier, won't it? Is that what you're thinking? Okay. What do you want to do for scale? Go by twos on both of them, or just on this? Okay. Alright, so what's the point that we know? We figured out that 1 pound of coffee costs $6.32, so that's going to be maybe, I don't know, there somewhere. What's another one that we know? And what is that? Oh, okay, so you just doubled it. 2 pounds is $12.64. We can fit 3 pounds on there. How much is 3 pounds? Is that what they told us in the very beginning? Okay. Alright, we really could have stopped after 2 points because I'm sure you guys all know this is a straight line. So 2 points would have done it. No pounds of coffee would cost no dollars. Truly. I mean, maybe if you like wanted to buy the bag that the coffee came in, they would be like, that's 15 cents just for the... Huh? Is that what you're doing? I need to change your reference. Maybe a coffee fee. In this situation, what is the meaning of the slope? What is the meaning of this? What is the meaning of the slope of the line? The cost per pound. Because the slope is the change in the y divided by the change in the x, and the y is the cost, and the weight is the x. Okay, number 7. Who's got the best job? Kel, my good friend Kel, yeah. Can I get a drink of water while you're at it? Yeah. Oh, I'm sure he's lying. Yeah, he just wants to go. He's going to go get a Cliff Bar. He's going to go inhale a Cliff Bar. Kel works in an after-school program at an elementary school. Hey, is the after-school program hiring, Abby? Oh, okay. You like work... well, I know that when the new sports season starts, some people can't work anymore, so they hire new people. But anyways, that's only like 2 hours a day, 4 days a week or something. Just trying to help. I'll keep my eyes open for a job for you. Kel works at an after-school program at an elementary school. The table below shows how much money, oh, Kel's a boy, he earned every day last week. So he worked for an hour and a half, got $12.60, 2.5 hours, $21, 4 hours, $33.60. Mariko has a job mowing lawns that pays $7 per hour. Who would make more money working 10 hours? So we got Kel, and we got Kel, and we got Mariko. What do you know? Anybody got anything? We could set up a proportion? You bet. So for Kel, we know, do you care which one of these we use for our proportion? Okay, so we know that if he works 1.5 hours, he gets $12.60. And so we need to figure out how much money he would get if he worked 10 hours, right? So how do you solve these proportions? Okay, so I'm going to multiply these two things together and these two things together. So 1.5x equals 126. So what does x equal? $84. Okay. All right, so Kel's going to make $84 in 10 hours. If Mariko makes $7 an hour, how much does she make in 10 hours? 7 times 10. Yeah, there you go. $7 per hour equals $70 for 10 hours, which is basically a proportion, but it's the easiest kind of proportion that you could ever have. So. Must be what? Oh, yeah. It's an old packet. All right, do you guys have a graph thingy or just a blank little space there? Just a blank space? Okay. So I guess you can just wing it because you're not as cool as me. You don't have your own graph paper. So this is going to be time. This is going to be money. All right. So I think for the time we can go by ones. How about for the money? Fives. So let's go 10, 20, 30, 40, 50, 60, 70. Okay. All right, so I have the points right there for Kel. So an hour and a half is going to be $12.60. So that's going to be right there-ish. 2.5 hours is $21. 21. And 4 hours is $33.60. So there's 35. Okay, what do you guys think about that? Is that okay? Yes, thank you, Weston. Your reassurance is important to me. Okay, so there is my BFF Kel. All right, what's a point that we know for Mariko? 70 and 10. Nice. Go right to the end of the story. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then all the way up to 70, which I barely put on my graph. Do we need another point for Mariko? 0, 0. No work, no money. I connect those 2 points. And that's the graph, so that is Mariko. Okay. Way to improvise, Luis. You want a ruler? Nope, you got it. Okay. Just count it. Okay, how could we tell, just from looking at the beautiful graph that we have made, who makes more money per hour. Kel, how come? Because he's higher. Jeez, here we go again. Kel, his graph is above Mariko's. Okay? So I'm not going to use the word higher, not because of the inappropriate connotations there, but just because maybe mathematically a better way to say it is Kel's graph is above Mariko's. So what's another thing that's true about Kel's graph? Steeper. Thank you. Kel's graph also has a steeper slope. We're going to do it, Luis. Aren't we almost done with this? Yeah? I mean, you were like, oh my God, it's such a but we're gonna get it, right? I guess. Okay, number 8, coffee and slope triangles. On the grid below, plot the points 1, 6.32, 2, 12.64, and 3, 18.96. Did those things, where did they get those from? Yeah, the coffee problem, remember? Those are the same points that we graphed already. So, if I got to get all the way up to like 19-ish, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if we go by twos, it should be good. And you guys can do whatever you want, but I'm going to spread out the ones on the bottom a little bit more. I felt like they were kind of bunched together. So I'm going to go 1, 2, 3, 4, 5, because then I feel like I can see that a little bit better. Okay, then we just need to plot the point. So 1, 6.32. Let's see, in the middle is 7, so that's a little bit there. 2, 12.64. And 3, 18.96. Okay, got it. Alright, are you ready for the craziness to begin? Okay, it says connect the first 2 points. So I'm going to connect these 2 points. Then it says draw a line straight down from 2, 12.64 and across to make a right triangle. So I'm going to go straight down from here and across from here. I don't know. I was just wondering the same thing myself. Okay, use the sliver method to draw a right triangle with the points 1, 6.32 and 3, 18.96. So let's do the same thing with the first and the third points. Maybe that's why they want us to do this. Make our lives happier. Okay? I was going to say, I think it has something to do with the Cliff Bars.
I was thinking like connect the 12 and then that like here. I just erased it. I didn't want to do it. And then I realized that we're supposed to connect like this one and this one together.
gonna text Mr. Pugh and talk about getting the drug dog back. Okay, how do these points relate to task number 6? Coffee by the pound. They are the same. Okay, number 2, how might you use these triangles to explain why this is a linear function? How do you know that it's a linear function because of those triangles? What would it look? Yeah. Let me do this. Let me put a point on here that would be not a linear function. And then let me draw the triangles that we would draw if we were using that point instead. So now, I don't want that color. So now, but that's what I'm saying is it's still going to be a right triangle. And there's still going to be straight lines. But what's the difference if I was doing the maroon one and the blue one instead of the maroon one and the green one? Well, how would you know if we looked at the maroon one and the blue one? How do you know that would not be linear? Because what? Because they don't what? Because what parts of them don't line up? Yeah, what's this part called? Yeah, but in a right triangle that's called the hypotenuse, yeah. So, because in this one the legs, this leg and this leg line up, right? And in the other one, the two legs, this leg and this leg line up, this one doesn't. The main thing is it's the hypotenuse that would not be lining up on top of each other. So let's go with that. Yeah. The two hypotenuses yeah, the hypotenuses are parallel. Yeah, that's true too. Okay. Yeah, I think we're done. That's all of lesson 2, right?